Hi, so today we will talk about modulation technique. Modulation technique are methods that use to input information onto a carrier signal which usually for transmission over a communication medium like radio wave, optic fiber or cable. Here is the diagram of modulation technique. Modulation are divided into two types, which are analog modulation and digital modulation. Analog modulation are divided into two types, which are continuous wave modulation and pulse modulation. Continuous wave modulation then divided into three types, which are amplitude modulation, frequency modulation, and phase modulation. Meanwhile, for phase modulation are divided into four types, which are pulse amplitude modulation, pulse wide modulation, pulse position modulation, and pulse code modulation. Meanwhile, for digital modulation is further divided into amplitude shift keying, phase shift keying, quadrature amplitude modulation, and frequency shift keying FSK. Next, we will talk about modulator circuit. For amplitude modulation, we will use switching modulator. Figure here shows switching modulator where contain carrier signal that is connected in a series with message signal, then connecting with diode in series, and there will be a generation of one signal that is V2. If V2 pass through the band pass filter, then amplitude modulated signal are formed. Next is a frequency modulation for modulator of frequency modulation. Frequency modulation is a technique or a process of encoding information on a particular signal, which are analog or digital, by varying the carrier wave frequency in accordance with the frequency of the modulating signal. For the modulator, we will use a narrow band frequency modulator. Here, the integrator is employed to integrate the modulating signal. The carrier signal is phase shifted by negative 90 degree to obtain a carrier signal using the negative 90 degree phase shifter. The product modulator accept two input, which are integration of message signal and carrier signal. It is given an output which is product of both the input. This is then multiplied with 2 pi kf by inserting a block 2 pi kf in the forward pass. Two input are given to the summer block, and they are nothing but the two term of NBFM equation. Both the carrier signal and the remaining term are given with positive and negative sign at input of the summer block. Finally, the summer block produce NBFM wave, which a narrow band frequency modulator. Next is modulator for modulation. We will use a multiplier modulator for ASK. Multiplier modulator is an electronic circuit that multiplies two input signals to provide an output proportionate to the product, and Those signal is known as a multiplier circuit. The fundamental is to combine the two input signals so that the output is their product utilizing part like transistor, operational amplifier or analog multiplier. An analog signal that reflect the multiplication of two input is often the end result. To put it simplify, the circuit receives two analog voltage as input signal and two output voltage is the result of multiplying the two signal. If you have two input voltage, like V1 and V2, the output will be V1 multiplied by V2 equal to V1 multiplied by V2. Next, let's move to BPSK modulator. For a PSK modulator, a balanced modulator with a binary sequence as one input and a carrier sine wave as another make up binary phase shift keying. A balanced modulator which multiplies the two signal applied at the input is used to modulate a BPSK. The phase reversal for high input is 180, while the phase with uh, 0 for the zero binary input. Depending on the data stream, the modulator's output sine wave will either be the direct input carrier or the inverted, which is 180 phase shifted input carrier. Next, let's move forward to the modulator circuit. For amplitude demodulation, the process is to extracting an original message signal from the modulated wave. The demodulator used is envelope demodulator. Envelope demodulator or envelope detector is for detecting the demodulating high level amplitude wave. Envelope detector include diode and low pass filter. Diode is the primary detecting device. The low pass filter has the resistor and capacitor in parallel. AM wave is given as input to the detector during the positive half cycle of the AM wave. The diode will conduct and the capacitor charge to the peak value of the AM wave. For those conditions, if AM wave value is less than shear value, the diode will be reverse biased. In those cases, therefore, capacitor will get discharged through the R until the subsequent positive half cycle of the AM wave. If the value of AM wave is greater than capacitor voltage, then the diode will become conducting and the process will be repeated. Next, for FM demodulator, we will use phase discrimination method. The diagram given contain the multiplier, the low pass filter and voltage control oscillator VCO. The VCO produce an output signal whose the frequency is proportional to the input voltage signal. Initially, when the magnitude of the signal is 0, the VCO must be made to produce an output signal having a carrier frequency and a phase shift of negative 90 degree about the carrier signal. FM wave and the output of the VCO are used as input of the multiplier. The output of the multiplier has a high frequency component and a low frequency component. The low pulse filter remove the high frequency component and give only the low frequency component as the output. The low frequency component has the term related phase difference only. Therefore, it has a modulating signal from its output of the low pass filter. For digital modulation, we have demodulation of ASK, demodulation of FSK, and demodulation of PSK. The demodulator for ASK will use a coherent detection. For AFK modulator, we use a synchronized FSK detector. And for the PSK, we'll use BPSK demodulator. Next, let's see the comparison between analog and digital modulation. As we can see, in the table, the bandwidth efficiency is more in digital modulation and less efficient in analog modulation. Next, analog signals are very prone to noise and interference. Any disturbance directly act on the amplitude, frequency, or phase of the signal. As noise increases, the quality of the signal continues to degrade. For example, static or distortion in the radio reception over AM and FM due to noise in the environment. While digital signals are more resistant to noise, they are operates upon the discontinuous state, namely 0 and 1. Small noise does not normally determine the decision between the state. The noise resistance can be increased by error correction method. For example, in the case of the noise in the TV, the transmission quality degradation does not occur until the critical value of the noise is exceeded. Digital modulation has a better noise resistance. Next, analog modulation technique normally have a simple implementation with fundamental components such as oscillator, amplifier, and filter. Analog systems do not call for complicated algorithm for encoding and decoding either. AM and FM radio are reasonable, simple in structure. On the other hand, more complex circuitry become necessary in the case of digital modulation, which include analog to digital converter, ADC, digital to analog converter, and complex signal processing. Error correction and synchronization further increase complexity in design. Contemporary cellular phone make use of complex digital modulation technique, requiring high processing power. Analog modulation, however, it is simpler in circuitry. And the last one is analog modulation are mainly applied in the cases of legacy system and application that require simplicity and low cost. Example include AM and FM radio, widely are used for broadcasting audio. Digital modulation dominate modern communication system due to its efficiency, reliability, and compatibility with digital device. For example, satellite communication employing high order PSK and QAM for data transmission. Digital modulation is more versatile and sees a wider use in a modern application. So that's it all from me. Thank you.